Good morning all, this is Nandhini, Assistant Professor, Department of Mathematics from AJK College of Arts and Science. Today we discuss about linear programming under quantitative techniques for management. What is linear programming? Linear programming or linear optimization may be defined as the problem of maximizing or minimizing a linear function that is subjected to linear constraints. The constraints may be equalities or inequalities. The optimization problems involve the calculation of profit and loss. Different types of linear programming. The different types of linear programming are as follows. Solving linear programming by simplex method, solving linear programming by graphical method, solving linear programming using R, solving linear programming with the use of an open solver. Next, advantages and uses of linear programming. The advantages of linear programming are as follows. Linear programming provides insight into business problems. It helps to solve multi-dimensional problems according to change of the conditions. Linear programming helps us in adjustment. By calculating the profit and cost of different things, linear programming also helps to take the best solution. Linear programming is very much used in the field of mathematics and some other fields like economics, business, telecommunications and the manufacturing fields. Next, linear programming applications. A real-time example would be considering the limitations of labors and materials and finding the best production level for maximum profit in particular circumstances. It is a part of important areas of mathematics, also known as the optimization of linear programming techniques. In order to find the most calculated solution to a problem with specified constraints, linear programming is utilized. We use linear programming to turn real-world issues into mathematical models. There is also an objective function as well as linear inequalities and constraints. The application of the linear programming in some other fields are given below. Engineering, it solves design and manufacturing problems as it is helpful for doing shape optimization. Efficient manufacturing, to maximize profit, companies use linear expressions. Energy industries, it provides methods to optimize the electric power system. Transportation optimization for cost and time efficiency. Importance of linear programming are, the linear programming is broadly applied in the field of optimization for many reasons. Many functional problems in operations analysis can be represented as linear programming problems. Some special problems of linear programming are such as network flow queries and multi-commodity flow queries are deemed to be important to have produced much research on functional algorithms for their solution. Next is component of linear programming. The basic components of the LPP are as follows. Decision variables, constraints, objective functions. The characteristic of linear programming. The following are the 5 characteristics of the linear programming problem. The first one, constraints. The limitations should be expressed in the mathematical form regarding the resource. Second one, objective function. In a problem, the objective function should be specified in a quantitative way. The next one, linearity. The relationship between 2 or more variables in the function must be linear. It means that the degree of the variable is always 1. Next is fitness. There should be finite and infinite input and output numbers. In case if the function has infinite factors, the optimal solution is not feasible. Non-negativity. The variable value should be positive or 0. It should not be a negative value. The last one is decision variables. The decision variable will decide the output. It gives the ultimate solution of the problem. For any problem, the first step is to identify the decision variables. The next one is method to solve linear programming problem. The linear programming problem can be solved using different methods such as the graphical method, simplex method, or by using tools such as R, open solver, etc. Here we will discuss the most important technique called the graphical method in detail. Once all the inequalities are plotted in the XY graph, the intersecting region will help to decide the feasible region. The feasible region will provide the optimal solution as well as explains what all values a model can take. Let us see an example here and understand the concept of linear programming in a better way. Solution. A set of values of decision variables xj, that is j varies from 1, 2, 3, etc. n, satisfying all the constraints of the problem is called a solution to that problem. Next is feasible solution. A set of values of the decision variables that satisfies all the constraints of the problem and non-negativity restriction is called a feasible solution of the problem. The third one is optimal solution. Any feasible solution which maximize or minimize the objective function is called an optimal solution. Next is feasible region. The common region determined by all the constraints including non-negative constraints, that is xj greater than or equal to 0 of a linear programming problem is called the feasible region or solution region for the problem. Next is mathematical formulation of a linear programming problem. The procedure for mathematical formulation of a linear programming problem consists of the following steps. First one is identify the decision variables. Second one is identify the objective function to be maximized or minimized and express it as a linear function of decision variables. The third one is identify the set of constraints, conditions and express them as linear inequalities or equations in terms of the decision variables. Next is types of optimum solution or special cases in optimum solution. The solutions obtained by the graphical method are of the following four different kinds. Type 1, no solution. When there exists no solution space, there is no solution to the given LPP. This is when there is no common region corresponding to all the constraints. Next, type 2. Type 2 is a unique solution. There is only one optimum solution for certain LPP. Next is type 3. It's an infinite number of solutions. Certain LPP have infinite number of optimum solutions. In such cases, the optimum value of Z is the same, but the values of the decision variables differ. Next is type 4. It's an unbounded solution. So, in some LPP, the maximum value of Z occurs at the point at infinity only. Next is graphical method. The graphical method is used to optimize the two variable linear programming. If the problem has two decision variables, a graphical method is the best method to find the optimal solution. In this method, the set of inequalities are subjected to constraints. Then the inequalities are plotted in the xy plane. Now let's see the problem from formulation of LPP. The question is given here. Your question is, a furniture dealer deals only two item vises, tables and chairs. He has to invest rupees 10,000 and a space to store at most 60 pieces. A table cost him rupees 500 and chair rupees 200. He can sell all the item that he buys. He is getting a profit of rupees 50 per table and 15 per chair. Formulate as an LPP so as to maximize the profit. This is your question, right? We have to formulate the LPP for this question. I think you all remember that the LPP has four main parts, right? What are the main parts? Variable, objective function, constraint and non-negative restriction, right? First we found the variable. Here they are given two items. What are the two items? Table and chair. So let us take our variable x1 as table and x2 as chairs, right? Our table is x1 and chair is x2, right? So our two variables are x1 and x2. x1 denotes table and x2 denotes chairs, right? Next is objective function. Your second part is objective function, right? Objective function. In your question, they are given that so as to maximize the profit, right? Here the word given the profit. Profit means maximization is it. So our objective function is maximum is it is equal to the profit of table is 50. Our table is x1. So 50x1. 50x1. Next, the profit of char is rupees 15. So char is our variable x2. So 15x2 plus 15x2. This is our objective function, right? So our variables are x1 and x2. Your objective function is maximization is it is equal to 50x1 plus 15x2. Here they are given the maximize the profit. Maximize the profit, minimize the loss, right? In your question they are given profit. Therefore maximum is it is equal to 50x1 plus 15x2, right? This is our objective function, right? Next third part is constraint, right? Next is our constraint part, right? Here they are given a dealer space to store at most 60 pieces, right? Therefore, x1 plus x2, number of tables plus number of chairs, stores at most 60 pieces. Therefore, less than or equal to 60, right? This is our first constraint. Next is they are given that a table costing rupees 500 and chair is rupees 200, right? Therefore, 500x1 plus 200x2. Here, the dealer invests rupees 10,000, right? Therefore, less than or equal to 10,000, right? This is our next constraint, right? Here, we cancel the two zeros from each term. We got 5x1 plus 2x2 is less than or equal to 10. So, this is our first constraint and this is our second constraint. So, we done variables, objective functions and constraint. What is the next one? Next is non-negative construction, right? Non-negative restriction. That is non-negative restriction means here we use two variables x1 comma x2 which is always greater than or equal to 0. That is non-negative. Non-negative means always greater than or equal to, right? Now, next is non-negative restriction. Non-negative means it is always positive, that is greater than or equal to. Here we use two variables, that is our x1 and x2 which is always greater than or equal to 0. This is our non-negative condition or non-negative restriction. Is it clear? Next, write the overall thing. Here is our LPP is your objective function. What is your objective function? Maximum is it is equal to, so our LPP is of the form maximum is it is equal to 50x1 plus 15x2 and subject to the constraints are x1 plus x2 less than or equal to 60 and 5x1 plus 2x2 less than or equal to 100. Next our restrictions are x1 comma x2 greater than or equal to 0. This is the LPP formulation of the given question, right? Our next example problem is for multiple optimal solution, right? Some special cases in LPP, some special cases in graphical method. Your first type is multiple optimal solution, right? Let us see the example. Maximum is it is equal to 4x1 plus 3x2. Subject to the constraints are 4x1 plus 3x2 less than or equal to 24. x1 is less than or equal to 4.5. x2 is less than or equal to 6. And x1 comma x2 greater than or equal to 0, right? This is your given LPP. We want to find the solution by using graphical method, right? Okay. First, let us consider these inequalities into equation. This is our first inequality, right? Let us consider that inequality into equation. Let 4x1 plus 3x2 is equal to 24, right? This inequality into equation. Now put x1 is equal to 0 in equation number 1, right? So 4 into 0 plus 3x2 is equal to 24. That is 0 plus 3x2 is equal to 24. That is 3x2 is equal to 24. So x2 is equal to 24 by 3. That is x2 is 8. So our x2 value is 8. That is, when I put x1 is 0, what is my x2? 8. Next, put x2 is 0 in the same equation. Put x2 is equal to 0 in equation number 1. So equation 1 becomes 4x1 plus 0 is equal to 24. That is, 4x1 is equal to 24 implies x1 is equal to 24 divided by 4. 24 divided by 4 is x1 is equal to 6. When I put x2 is 0, what is my x1? 6. I put x1 is 0 means my x2 is 8. I put x2 is 0 means my x1 is 6. Now we have to plot these points in the graph sheet, right? So when x1 is 0, my x2 value is 8. This is our x1 axis, this is our x2 axis. When my x1 is 0, what is my x2? 8. So 0, 8. Next, my x1 value is 6. This is our x1 axis. Here x1 value is 6. What is your x2 value? This is our x2 value, x2 axis. In x2 axis, the value is 0. So 6, 0. Join this line. Join these points. Next, consider the second inequality into equation. Here your inequality is x1 is less than or equal to 4.5. We consider this inequality into equation. Our equation is x1 is equal to 4.5. This is equation number 2, right? So we have to plot this point into this graph. So x1 is equal to 4.5, right? This is my x1 axis. 4 is here, so 4.5 is here. So 4.5. So x1 is equal to 4.5. You write the line here. 4x1 plus 3x2 is equal to 24. Next, your third constraint is x2 is less than or equal to 6. Consider this inequality into equation. What is your equation? x2 is equal to 6. So our next equation is x2 is equal to 6. This is equation number 3. Now we plot this equation into the graph. So x2 is equal to 6. This is our x2 axis. x2 is equal to 6. So this is my 6. So x2 is equal to 6. Is it clear? Next, the given constraint is less than or equal to 10. All the three constraints are less than or equal to 10. So we have to shade below the lines, right? We have to shade below the lines. Next, we have to find the solution space. The solution space is this one: O, A, B, C, D. This is our solution space. O, A, B, C, D is our solution space, right? The coordinate of O is 0, 0. The coordinate of A is 4.5, 0, and the coordination of B is the intersecting line of x2 is equal to 6 and 4x1 plus 3x2 is equal to 24. By using these two equations, we have to find the coordinate points for B, and the coordinate points of C is the intersecting line of 4x1 plus 3x2 is equal to 24 and x2 is equal to 6. By using these two equations, we have to find the coordinate value for C, and the coordinate point for D is 0, 6, right? So O, A, B, C, D is our solution part, right? Coordinates of O is, coordinate of O is 0, 0. And coordinates of A is x1 left 4.5 and in place of x2 0. So 4.5, 0. Next, coordinates of B is, what is B here? B is the intersecting line of x1 is equal to 4.5 and 4x1 plus 3x2 is equal to 24. Intersection of x1 is equal to 4.5 and x2 is equal to, and 4x1 plus 3x2 is equal to 24. By solving these two equations, we have coordinates of B, right? Next, coordinate of C is, what is C? C is here. So, it is an intersection of 4x1 plus 3x2 is equal to 24 and x2 is equal to 6. Next coordinate of D. D is in place of x1 0, in place of x2 6. So 0, 6. Right? Next, by solving these two equations, we have to find the coordinate points of B and the coordinates of C. So take this one. x1 is equal to 4.5 and 4x1 plus 3x2 is equal to 24. Now substitute x1 is equal to 4.5 into this equation. Put x1 is equal to 4.5 in 4x1 plus 3x2 is equal to 24. So 4 into 4.5 plus 3x2 is equal to 24. 4 into 4.5 is 18 plus 3x2 is equal to 24. From this 3x2 is equal to 24 minus 18. 24 minus 18 is 6. So 3x2 is equal to 6. x2 is equal to 6 by 3, that is 2. So our x2 value is 2, our x1 value is 4.5. So coordinate of B is what? Coordinate of B is 4.5, 2. Is it clear? Next is coordinate of C is intersection of 4x1 plus 3x2 is equal to 24 and x2 is equal to 6. Similarly, we have to solve this one. So, put x2 is equal to 6 in 4x1 plus 3x2 is equal to 24. So, 4x1 plus 3 into 2 is equal to 24. 4x1 plus 6 is equal to 24. That is 4x1 is equal to 24 minus 6. That is 4x1 is equal to 18. So x1 is equal to 18 divided by 4. Right? This is equal to 2 2s are 4. 9 2s are 18. 1 2s are 2. 4 2s are 8. That is 4.5. So our x2 value is 6 means, our x2 value is 6 means our x1 value is 4.5. Therefore, the coordinate of C is 4.5 comma 6, right? The coordinate point of C is 4.5 comma 6. 4.5 comma 6. Now we have to find the maximum Z value, right? Maximum Z value. Next, we have to find the maximum Z value, right? Maximum value at O. At O is, what is O value? 0, comma 0. So, in place of x1, substitute 0. In place of x2, substitute 0. So, 4 into 0 is 0. 3 into 0 is 0. So, your maximum value at O is 0. Next, objective function at A. At A is, what is your x1 value? 4.5 and x2 value is 0. So 4 into 4.5 plus 3 into 0. This is equal to 18 plus 0 is equal to 18. Next, objective function at B is 4.5 comma 2. So your x1 value is 4.5 and x2 value is 2. So objective function at B is 4 into 4.5 plus 3 into 2. So 4 into 4.5 is 18 plus 3 into 2 is 6. So 18 plus 6 is 24. Next, objective function at C is 4 into 4.5 plus 3 into 6. 3 into 6. So this is equal to 18 plus 18 is equal to 36. Next, objective function at D. So objective function at D is 4 into 0 plus 3 into 6. This is equal to 18. Right? Consider the value 0, 18, 24, 36, 18. Right? Here, which is the maximum value? 36. So, our objective function is maximum at C. That is, our objective function is maximum at x1 is equal to 4.5 and x2 is equal to 6. This is our solution. Our next problem is maximum z is equal to 3x1 plus 2x2. This is our objective function. The constraint part is x1 plus x2 less than or equal to 1, x1 plus x2 greater than or equal to 3. Non-negative restrictions are x1 comma x2 greater than or equal to 0. We have to find the solution by using graphical method, right? Here, your first inequality is x1 plus x2 less than or equal to 1. You have to consider this inequality into equation. So, x1 plus x2 less than or equal to 1 becomes x1 plus x2 is equal to 1. This is our equation number 1. So, put x1 is equal to 0 in equation 1. So, 0 plus x2 is equal to 1. x2 is equal to 1. I put x1 as 0. What is my x2? 1. Similarly, put x2 as 0. So, put x2 is equal to 0 in 1. So, x1 plus 0. x1 plus in place of x2 substitute 0. x1 plus 0 is equal to 1. That is x1 is equal to 0. I put x2 equal to 0. What is my x1? 0. Sorry, 0. Sorry, 1. So now we have to plot the graph for this point, right? This is our x1 axis, this is our x2 axis. So 0, 1, 0, 1 and 1, 0. So what is the equation for this line? x1 plus x2 is equal to 1. x1 plus x2 is equal to 1. Next, consider the second inequality into equation. What is your second inequality? x1 plus x2 is greater than or equal to 3. This is your inequality. Consider this inequality into equation. It becomes x1 plus x2 is equal to 3. Put x1 is equal to 0. 0 plus x2 equal to 3, that is x2 equal to 3. I put x1 is 0 means my x2 value is 3. Next, put x2 equal to 0. Put x2 equal to 0 implies x1 plus 0 equal to 3. So x1 equal to 3. If I'll put x2 equal to 0, we get x1 is equal to 3. Now we have to plot the graph for this points, right? This points into graph. So 0, 3. In the x1 axis 0, in x2 axis 3. In x1 axis 3, in x2 axis 0. So the equation for this line is x1, x2 is equal to 3. Right? Now we have to find our solution part, right? In this first inequality is less than or equal to 10. Less than or equal to type means inside the line. So this is our solution part, right? Next inequality is greater than or equal to 10. Greater than or equal to type means upwards, right? Any common region here, there is no common region, right? Therefore, there is no solution for the given LPP. Is it clear? Your next example for unbounded solution. The question is here. Maximum is equal to 3x1 plus 5x2 and subject to the constraints are 2x1 plus x2 greater than or equal to 7, x1 plus x2 greater than or equal to 6, x1 plus 3x2 is greater than or equal to 9. And the non-negative conditions are x1, x2 greater than or equal to 0. This is your given LPP. We want to find the solution for the given LPP by applying graphical method, right? So, your first step is consider this inequality into equation. This is an inequality. Consider this inequality into equation. So, it becomes 2x1 plus x2 is equal to 7. This is your equation number 1. Now, put x1 is equal to 0 in 1. So, 2 into 0 plus x2 is equal to 7. That is 2 into 0 is 0. 0 plus x2 is equal to 7. So x2 is equal to 7. When my x1 is 0, what is my x2 value? 7. Next, put x2 is equal to 0. Put x2 is equal to 0 in equation 1. So 2x1 plus 0 is equal to 7. So 2x1 is equal to 7. From this, x1 is equal to 7 by 2, that is 3.5. So, when my x2 is 0, what is my x1 value? 3.5. Next, we have to plot the graph for this points, right? x1, x2, 1, so 0, 7. In x1 axis 0, in the x2 axis 7. 0, 7. Next in x1 axis 3.5, x2 axis 0. In the x1 axis 3.5, in the x2 axis 0. So 3.5, 0. Join these points and write the line. 2x1 plus x2 is equal to 7. Right? Next, consider the second inequality into equation. What is your second inequality? Here x1 plus x2 is greater than or equal to 6. Consider this inequality into equation. So let x1 plus x2 is equal to 6. So put x1 is equal to 0 in equation number 2. So in place of x1 substitute 0. 0 plus x2 is equal to 6. So x2 is equal to 6. My x1 is 0 means x2 value is 6. Next put x2 is 0. So put x2 is equal to 0 in equation 2. It becomes x1 plus 0 is equal to 6. So x1 is equal to 6. Put x2 equal to 0. We have x1 is equal to 6. Now plot the graph for this points. In x1 axis 0, x2 axis 6. In x1 axis 6, x2 axis 0. Join these points and write the line. What is your line? x1 plus x2 is equal to 6. Right? What is your third constraint? Third constraint is x1 plus 3x2 is greater than or equal to 9. Let us consider this inequality into equation as usual. So x1 plus 3x2 is equal to 9. This is your equation number 3. Put x1 is equal to 0 in equation 3. It becomes 0 plus 3x2 is equal to 9. So 3x2 is equal to 9. So x2 is equal to 9 by 3, it is 3. When my x1 is 0, what is my x2? 3. Similarly, put x2 is 0. Put x2 is equal to 0 in equation 3. It becomes x1 plus 3 into 0 is equal to 9. x1 plus 0 is equal to 9. So x1 is equal to 9. So when x2 is 0, our x1 value is 9. So now we have to plot the graph for this point. x1 is 0, x2 is 3. In the x1 axis 0, x2 axis is 3. 0, comma 3. Next, in x1 axis 9, x2 axis 0. In the x1 axis 9, x2 axis 0. 9, comma 0. Join these points and write the line. x1 plus 3x2 is equal to 9. Now we have to find our solution part, right? Here all the constraints are greater than or equal to 10. Greater than or equal to 10 means the region is upwards, right? So all the 3 line segments are having the regions upwards. Upwards means there is an endless region, right? So your solution is unbounded. That is our solution part is unbounded, right? There is no limit point, right? Therefore, our solution is unbounded. So this problem having unbounded solutions, right?